So in looking at problem 18, we're looking at a buffer problem here. The first thing you're going to need to do is find the initial moles of the AH or the A-, depending on what you're looking for here. We're looking for the A-, that's going to be our focus. I'm going to find the moles of AH anyway, because I want to show you something else with regard to the calculation here. But let's look at the, first of all here, the moles of AH here. And we'll look at initial moles here. The moles of AH is going to be 0.752 moles per litre times 0.6074 litres. So that's going to be the volume used of each of those. But that's going to be milliliters converted to litres. And 3 sig figs is going to be 0.457 moles. Moles of A-, do something similar. It's going to be 0.760 moles per litre times 0.6704 litres, and that comes out to be 0.462 moles. Now we can get the moles of H+, based on how much we're using there. That's going to be 0.511 moles per litre times, in this case, the volume used of that is 0.02967 litres. So again, that milliliter value converted into litres, and it comes out to be 0.0152. You'll notice moles. You'll notice it's different. So it's less than both of those, but you see there. Now, in order to get the reaction moles, and we're just interested in the moles of A- here. The reaction moles are going to be the moles of A- will equal the initial moles of A- minus the initial moles of H+. And that means it's going to be, for this one, 0.462 moles of A- minus 0.0152 moles of H+. And that's going to be 0.447 moles of A-. Now, for justification here, I can draw this out as a picture. See, initially we've got approximately equal amounts of A- and AH in this flask here. Or in the speaker. Let me get rid of that. Let's try that again. There we go. That's better. It's better. And what we're doing is we're adding H+ to this. Now, if the H+ isn't going to react with the AH, it will react with the A-. And what's going to happen is, for every H+ that it gets added, an A- will react. Also, the AH is going to go up as well. But the important point for this problem is that every mole of H+ added creates a decrease in the amount of A-. 1 mole decrease of A- in the solution. And you can see the same things happening here. So for every mole of H+ that gets added, we're losing that amount of A-, and that gives us our final amount of A- there.